All right, hey guys, I am going to go over the review with you. You'll need to have the review pulled up or in your hand while you're doing this, and you'll probably need to pause, toggle back and forth, or just go ahead and print it out if you didn't get a hard copy. So I'm just going to go through the scientific method stuff first. So if you have number one, how do you identify an independent and dependent variable? The independent variable is the thing that the scientist is manipulating, and the dependent variable is what they're measuring. So I will give you a data table, and I will ask you which one is the independent, which one is the dependent. So it should be pretty straightforward. So anytime I finish answering a question, you need to write something down. Go ahead and pause because I'm going to move on. Number two, what is the purpose of a control? It's a basis of comparison. And it makes sure that the variable being tested is the actual variable that's having an effect. It can be that too. Number three, what is the difference between a positive and a negative control? A positive control is a treatment that you already know the outcome for. You use that as a basis of comparison. A negative control would be have no treatment at all. So it would be empty, blank, nothing there. Like with the pill bugs, if you had an empty chamber that you were had as one of your choices, that would be a negative control. All right, we already did number 4 in class, so I'm not going to go over that again. Null and alternative hypotheses. Make sure you go back and review the video, the Bozeman Science video, if you're confused on that. The M&M lab. But a null hypothesis would be, there is no significant difference between what is expected and what is observed. The alternative hypothesis would be, there is a significant difference between what is expected and what is observed. And we make that determination based on a chi-square problem. All right, and so I have here my slideshow for chi-squared. One of your FRQs is going to be a chi-squared problem. And so you will be given the formula like this. You'll be given the critical value chart, but you do need to know how to use this formula. So if you're given data that's giving you observed results, you're going to want to figure out what would the expected be. So remember, for expected, if there's no like rule or law or some kind of report telling you what you're supposed to get, you assume all outcomes are equally likely. So like with your pill bugs, all the outcomes would have been equally likely. That's what you would have expected. All right, and then once you have calculated your chi-squared, you'll find a p-value of 0.05. You need to figure out your degrees of freedom. Remember, to figure out degrees of freedom, it's the number of categories minus 1, and you find the number. So this number in this chart is the critical value. If your calculated chi-squared value is bigger than the critical value, you reject your null hypothesis. If your calculated value is smaller than the critical value, you accept the null hypothesis. I'm just going to go ahead and use the word accept on your test. I know that makes some people mad, but that's okay. Just answer it right. Just humor me. You would have the word accept. I didn't feel like changing. That's actually a multiple choice question that I'm using from a prior year, and it said accept, so I just left it. And I made my copy, so I can't change it now, so get over it. I'm just kidding. I'm not. All right, moving on. Number 7, what makes an experiment more valid? I feel like we had a slide on that, but I don't know where it went. I'll just tell you. More trials, a testable hypothesis, large sample size, making sure you account for any of the constants, like making sure the constants stay constant, and then having a good control group. Yep. All right, number 8, claim, evidence, and reasoning. What do each of these mean? Claim is you just make a sentence based on what you see. The pill bugs liked pineapple the best, and it was significant. Your evidence would be your data tables and your chi-squared calculations or your calculations. And your reasoning would be, why did they like the pineapple the best? Is it because it had more sugar? Is it because it had more water in it? Is it the texture? Is it the color? Your reasoning would just be an explanation as to why. Okay? Now we did number 9 in class. Number 10, I feel like we did do that in class. If you're looking left to right and they overlap, it's not significant. If they don't overlap, it is significant. All right, we did number 11 and 12 in class. All right. I'm not going to bring up the whole slideshow for number 13, but please look back at your chapter 1 notes. Let me tell you the page number, actually. I'm going to be nice and do that. In your binder, it is on page 23. What makes something living? Growing, developing, homeostasis, evolution, responding to the environment, reproducing, possessing metabolic processes, and possessing a lifespan. That is on page 23 of your notes. I'm not going to bring up the slideshow for that. That's too much work. Why is a virus non-living? A virus only evolves. It does not, it doesn't regulate, doesn't have homeostasis, doesn't reproduce. Well, I mean, okay, it doesn't reproduce without a host. It doesn't reproduce without a host. It doesn't have metabolic processes, stuff like that. So a virus is non-living. All right. I'm not doing chapter 3. Why did that come up? I'm going to do chapter 2, chemical context of life. That's where we are now. Okay. Sorry, I know my clicking makes like weird noises, and I was doing my fingernails and that probably made a bad noise, but that's okay. All right, the number 15, what 4 elements make up 96% of living things? There they are: oxygen, carbon, hydrogen, nitrogen. What is a trace element? Give an example. A trace element is an element that is necessary for life, but only in small quantities. And your example would be iron. All right, I'm moving on. Number 17, what is a covalent bond? A covalent bond is sharing of electrons between 2 nonmetals. Sharing of electrons between 2 nonmetals. Number 18, I answered for you. Carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, chlorine. God, I feel like something's missing off that list. Oh, fluorine. I guess I'd put the F there too. So number 18 is answered for you. What is electronegativity and how does it relate to polarity? Electronegativity is the ability of an atom to attract electrons. The more electronegative something is, the more likely it's going to attract electrons. And it has different reasons for doing that. Part of the reason would be the positive charges in the nucleus. So when you go up and to the right on the periodic table, I hope I'm not saying this wrong, up and to the right, you increase electronegativity. Now your noble gases are not going to have electronegativity because they're already stable, they're already perfect. They don't need anyone else's electrons. But what would be your most electronegative atom? It would be fluorine. It is the most upper right, yeah, fluorine. So fluorine would be the most electronegative. So anything that's close to fluorine would also be electronegative, like oxygen. Nitrogen is electronegative. They're pulling electrons towards themselves. Most specifically for this class, they're pulling them away from hydrogen. And so what that does is it results in partial charges, because the more electrons one has around itself, the more negative it's going to be. The less electrons something has around itself, like hydrogen, the more partial positive it's going to be. All right, hopefully that made sense. Number 20, C6H12O6 is glucose. It's a sugar. What can you say about the bonding and polarity? Covalent bonds, and it is polar. I just want you to know sugars are polar. What kind of bond is between H and Cl and hydrochloric acid? Well, H is a nonmetal. Chlorine is a nonmetal. That must be a covalent bond. Are they polar? Yes. Chlorine is really close to fluorine. Hydrogen's all the way over on the left. So yes, we could say that's polar. And then when it's in water, it actually would break apart. We're not going to get into that though. All right, draw a structure of H2O and use symbols to represent its polarity. Boo, 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 boo. Where am I going? I'm going all the way back. Okay, wait. That's actually on your notes. You have a really good picture of just water. No, dude, it's supposed to be on here too. Sorry, I'm going so fast. Oh my God, it was on the slide I was on. Wow, I'm embarrassed. I'm not gonna edit this, I'm sorry. So yeah, here's water right here. This is the picture that you're drawing for number 22, and use the symbols to represent polarity. So the reason why there's polarity is because it's a covalent bond. They're 2 nonmetals. Hydrogen and oxygen are nonmetals. They're sharing electrons, but they're sharing them unequally. Therefore, oxygen is pulling the electrons towards itself. Electrons are negative, so it's gonna have a partial negative charge. And then hydrogen is gonna have a partial positive. All right, what is an ionic bond? It is the complete transfer of electrons between a metal and a nonmetal. Give an example of an ionic compound, NaCl. What are ions? Give an example of an ion. So I'm on number 25. I know I'm going fast, but y'all can pause. An ion is an atom or a compound that holds, I should say that, not this. I should say that. An atom or a compound that holds an electric charge, and it's due to an imbalance between protons and electrons, and the reason that happens is because there's a complete transfer of an electron or so. Give an example of some ions. Na+, Cl-, H+, K+, Ca, which is calcium, 2+. Calcium gave away 2 electrons. Oh my gosh. So then it has a positive 2 charge. I'm trying to think if there's any other negative ions we use in this class. Oh my gosh, I'm drawing a blank. Oh, you need to know phosphate. Phosphate, PO4, 2-, right? No, 3-. PO4, 3- is phosphate. Let me check myself. If I get this wrong, I'm going to edit it down. I forgot. I know it's PO4, 3-. Please tell me I'm right. Yes, I'm right. PO4, 3-, and I'm supposed to know that. You're going to want to know about phosphate when we talk about DNA. Okay, what else? I think we're good on that. Number 26, what are hydrogen bonds and what can you say about the strength? They are weak bonds, but strong attractions. It is the strong attraction between the partial positive of a hydrogen on one polar compound and the partial negative of something like oxygen, nitrogen, sulfur on another polar compound. It's just an attraction. And you notice that it is dotted lines. It's an attraction. If you get a partial negative and a partial positive together, they're going to be attracted to each other because opposite charges attract. Okay, we answered number 27. Cool. Number 28, I mean, it's actually good practice to draw it. I'm just skipping. This is a thing I'm trying to get you to draw on number 28, so have fun with that. Let me know if you have any questions in email. Shape affects a molecule's function. Properties of water. All right, I told you what cohesion was. I told you what adhesion was. Told you about high specific heat right here. Okay, I'll stop clicking because it's annoying. I told you about density and I told you that water is a really good solvent. So the question on number 30 is asking which properties of water above contribute to the following. So what contributes to transpiration? Well, you got to know what transpiration is. I'm telling you there's a question on your test about it. Transpiration is the movement of water up a plant. It's caused by various things. One of those things is root pressure, pushes the water up. Another one of those things is water's evaporating out, pulling other water molecules through the vascular tissue. Well, why is it that water gets pulled through? If it's evaporating out of the top and it's turning into a gas, why is it still pulling the liquid through the plant? And the reason is because of cohesion, because water clings to other water molecules via hydrogen bonds. Water is also clinging to the sides of the vascular tissue, which is made of a sugar called cellulose, by adhesion. Cohesion and adhesion is water attracted to or hydrogen bonding to other water, cohesion, or other polar molecules, adhesion. That's your answer to that. Evaporative cooling. What is it asking? Oh, evaporative cooling. So water has a high specific heat. It also has a high heat of vaporization. For our purposes, we're just gonna use those synonymously. If it can absorb a lot of heat without changing temperature, I mean, of course it can absorb a lot of heat without evaporating. So we're gonna use those synonymously. So that's what evaporative cooling is. The water absorbs heat, then it evaporates, it leaves the living thing, taking the heat with it. Right, insulation. Water's density is lower when it freezes. So therefore it floats and it insulates the water underneath it. All right, surface tension, that's back here. Surface tension. is a direct result of cohesion, water, hydrogen bonding with other water molecules. All right. Dissolving. Does dissolving have 2 S's? I wonder if anyone's actually going to watch this video. Ooh, okay. Ooh, dissolving does have 2 S's. Thank goodness. All right, dissolving polar molecules and ionic compounds. What is it about water that makes it good at dissolving polar molecules? Because it's a polar solvent. It's a polar solvent. That's why. Great. Number 31 we did in class. Number 32 we did in class. Last thing on there is acids and bases. Acids are going to increase hydrogen concentration, hydrogen ion concentration. Hydrogen ion is also known as a proton, remember that. Has a pH of less than 7. A base reduces hydrogen ion concentration. It has a pH of greater than 7. All right, so if I didn't get to tell your class, there are 25 multiple choice. Covers everything. Scientific method, independent variable, dependent variable, control group. It covers all of this chemistry stuff. Polarity, hydrogen bonding, covalent bonding, properties of water, all of that stuff. You then have 2 FRQs. The first one, I'm going to give you a data table. You're going to need to graph it. The second one, I'm going to give you a scenario, an experiment. You need to tell me just a couple of things about the experiment, and then you're going to do a chi-square calculation for it. I don't think everyone will be pressed for time. I would say move quickly. The multiple choice should not take you any more than 35-40 minutes. That leaves you 35-40 minutes for the FRQ. So you're going to want to move quickly, as quick as you can, and pace yourself. I'll put a timer up. Okay, email me if you have any questions. 17 minutes. I think that was pretty good. All right, talk to you later. Bye.